break, and I'd like to welcome you all to my presentation on innovating smart and sustainable built environments. Today's presentation is going to be slightly different from what you are used to, in the sense that I don't want to go too technical on the common practices that we do in sustainability. So I want to try to alter your perception and perspective on sustainability, and I'm just going to try, just to scratch the shell of your minds for you to, think about sustainability in a different process. So first of all, let's define what is sustainability. And I'm not going to go to the definition, it's right here on board. And I'm not sure if you guys can read it. Can anybody read it? You guys can read it? Too small? Okay. So how many of you are familiar with this definition? Too small. Should I read it? Is that okay? Yeah? Sure. Okay. How many of you believe that what we do today in our building sector is actually in line with this statement? Anybody? Okay, interesting. All right, and okay, someone over here kind of raised their hand, right? So Miss, can you please just elaborate why do you think we are doing so? Okay, good. All right. Okay, so when we are talking about the statement with what we are trying to do in the common practice, basically we're looking at, just saving energy, water conservations, we're looking at recycled content, regional materials, etc. And that is kind of, in a way, for us to preserve the environment and reduce carbon emissions and greenhouse gases. Now, that is when it comes to the new construction. When it comes to retrofitting, on the other hand, we are looking at, for example, changing light fixtures, changing some, taps over water, changing the glass and envelope materials, in a way for us to get it in line with, again, harnessing the environment and making sure that we are, saving the best resources for future generations, of course. Now, how is it measured? Usually, and this is a wrong perception, is that people tend to kind of accommodate sustainability with, let's say, LEED or other rating systems. Unfortunately, sustainability cannot be measured by a rating system. A rating system can just give you, kind of like an indicator of where it stands in terms of its performance. But it does not tell you exactly how much is that building actually impacting the environment. So this is what my presentation is going to be talking about. In my presentation, I want to split two systems which I would really like to focus on. One is the construction system, that what we're doing today in our construction industry. And the next one is the ecosystem, which is the basic environment, Mother Nature. And I want to see if we can derive to a conclusion of whether we are at a balanced life, if we are actually in line with nature, are we, at equilibrium, or are we a little bit far off? So to start with, let's just understand the systems a little bit more better. So the construction system is arguably one of the most intensive resources that is damaging the environment, because we rely on the raw resources a lot and very heavily. Next, the construction model is actually more of a linear flow than it is of a system, in a sense that, you extract the materials, we process them, we manufacture them, transport them, build it, and then we just dump it. Unfortunately, that's the case. Now, luckily, we are still, right now, we're looking at, trying to recycle the material back. However, given the infrastructure in different countries, we're still not at a situation where recycling is actually prosperous. On the other hand, if you look at the last statement over there, the construction industry is actually producing, it's actually using up around 3 billion tons of raw resources. Now, out of which, for every kilogram of raw resources utilized in buildings, in the building sector, we are producing around 20 kilograms of waste. Can you imagine? For every kilogram, 20 kilograms of waste. Now, what's happening to that waste? Let's look at it a bit closer. Now, if we look at the ecosystem works a little bit differently in the sense that the ecosystem has been created, in fact, in a way, it should never run out of resources. We should never run out of water, we should never run out of oil and other minerals, right? However, because of the high demand, it's on shaky grounds right now, right? On the other hand, you have, it follows like a cyclic process, which is a little bit different from the building industry, in the sense that everything is within a loop. It's a closed loop. It's a chain of supply, demand, utilize, and then recycle. It's all within the same loop. It's a closed cycle. Now, the last statement, which is interesting for me, is that, you see, when we're looking at nature, it tends to react with every object species that lives on this planet. So when an alienated object, such like a building, comes into play, what happens is it either blends in with it, so it works perfectly fine and in harmony with nature, or it actually adapts to it. So yeah, there's a little bit of a sacrifice, but it's still within its equilibrium range, or it kind of destroys it. So nature would work against you in order for it to restore its equilibrium. In a sense, and this is what I'm talking about, is that it just follows a closed cycle. We have the plant subsystem, which is also a closed cycle, water cycle, we have the plants, the soil, rocks, etc. It all works in a closed cycle. There is minimal waste within Earth. Now, so the key here is, it's a closed cycle. So where do we stand? Right now, we have already utilized an additional 25 years of raw resources. So from now to imagine, like we have already used up raw resources to around 2040. Can you imagine? 25 years of resources already gone. With that, 4/5 of the world's population in countries have used more than their own natural systems can actually provide for in their local environment. So imagine you're in countries where you have no resources and you're also utilizing other people's resources. Now, if we look at the main 6 minerals which is water, oil, natural gas, phosphorus, and coal, we would see that water, based on the Food and Agriculture Organization and the United Nations, they have estimated that we have around, that in 2025, around 1.8 billion people are going to be running on absolute water scarcity. Can you imagine? That is a big number. Then if we look at oil, based on British Petroleum, when they have measured it in 2010, they have found out in proven reserves that we have enough oil to supply us for the next 46 years. Minus 5 years already, we're almost 2015, so that means we're looking at 41 years of oil left. If you look at natural gas, on the other hand, okay, we have enough natural gas in proven reserves for the next 60 years almost. Again, that's a short number, right, of years. If we're looking at phosphorus, and you might think, why phosphorus? Well, phosphorus is an important mineral for plants to grow. Imagine if we are going to run out of it somewhere between 50 to 100 years from now, based on measured resources, okay? Imagine what would happen to the world if there are no more plants in the world. What are we going to eat? How are we going to breathe? Everything's going to be deteriorating, right? If we look at coal, well, fortunately enough, we have enough coal for the next around 200 years, so that's close. So, remember my first statement about ecosystem. Nature can restore its own order. If we give it a breathing space, it can go back to its equilibrium, and we might not run out of resources too soon. But the question is, can we, in this industry, kind of put our production on hold for the next 25, 30 years? Do you think that's practical? No, right? I mean, can you imagine? No more jobs, no more factories, no more, sounds of cranes and construction bothering you at night? No, right? That's not going to happen. So what I'm presenting here today is something for you to just think out of the box for a second and start tackling sustainability rather than at the very end, which is the building, for example, how can we save more energy or water, etc. Because at the end of the day, that's just at a building level. We are not changing the process. In order for you to have a good, sustainable process, you need to change the way you think about sustainability. We need to change our perception from that, going to that linear flow of materials and the chain of, interactions throughout that flow from start to finish. We need to think of, learning from the ecosystem and try to have a good closed loop where we actually kind of recycle our own waste and we no longer have to, depend on the nature and its neural resources for it to give us the materials. Instead, by doing that, we would actually be able to reduce the time frame that we have seen, and we would give nature some time for it to actually get back in line with its equilibrium. So let's kind of redefine our sustainability perspective, and this is what I was just giving you. Let's change our perception from a linear flow to a cycle loop. Can we do that? Let's see. Now, my next section is going to be talking a little bit more about case studies from around the globe that kind of touched bases on this concept, this theory, and it's something that we are researching here. Again, this is just a theory at the moment, so it's not tested, but again, the case studies prove a good platform for this. So if we're looking at a master plan level, I'm going to go from the macro scale and then I'm going to zoom into the micro scale. So bear with me for a second, please. Eco-industrial city parks. What is an eco-industrial park? Now, the city of Kalundborg in Denmark is the first world's eco-industrial park, and it was created in 1992. Now, the eco-industrial park goes around the basis of shared infrastructure. In essence, what it means is that the waste from, let's say, a factory X becomes the raw resources for factory Y. Of course, there are treatment plants. It works in a closed cycle. Basically, what they're trying to do is no longer depend on outside resources, but rather whatever they've already gotten is going to be used within the same chain. Now, it's been running since 1992 very successfully, and it's a very good example of such a park. It offers a good environmental benefit, an economic benefit, of course, and a very strategic element to the country. This is the model, this is how it works. So you have the power station, you have the refineries, you have different farms, animal farms, fish farms, plants, yes. And then you have the different factories, and the way it works is that everything is working within the same loop. Of course, waste is inevitable. We cannot have a zero waste, absolute zero waste within any city. But again, we could kind of limit the need for new resources. Next, we're going to look at the community microgrid. So I'm just zooming out from the large scale, and I'm going to focus a little bit more deeper within dividing the master plan into different communities. The community microgrid is an initiative that basically relies on renewable energy in such a way that it could actually offset the need for electrical power from fossil fuels by 25%. Now, how that works is that they install renewable energies on top of buildings, on windows, on cars, on your phones, etc. And that basically moves you from a centralized generation of power, of your municipality power, to a more localized energy generation. So the way it does is that you have the renewables, it follows a grid distributed across this community, and then it feeds into the different components such as the buildings, charging up for electrical cars, for example, etc. So you are kind of putting the energy together within this community and putting it into effectiveness rather than on a building scale, but rather on a community level. So imagine 25% of your energy saved for all different buildings across the community through these initiatives. Next, we're going to look at a biosustainable building. Now, this is where our theory and research is being conducted at the moment. It's not a finished product, so please just bear that in mind. If this one's work. Okay, so the biosustainable building. What it does is basically what we are suggesting here. I hope it comes back. Okay, all right. The way it works is that we are trying to go away from the common norm of designing an airtight building and a watertight building. Now, most of you are going to come to me and you're going to go like, no, you cannot do that because this way you are actually going to use more energy and your demand on the chillers, on your mechanical power is going to be even higher. No. Now let's look a little bit closer. What we are suggesting here is actually designing and creating, constructing smart envelopes that actually work as renewable energy. They're membranes. They function exactly like a leaf of a tree. It breathes, it gets your bacteria out, so you're no longer stuck with that tight building that creates a sick building syndrome and everybody gets sick and the virus kind of spreads and everybody in the office takes a good leave because of just an indoor air quality issue, because we wanted to save energy. You can do it in different ways. So this membrane, okay, would be elastic, it would be thermal, it would function exactly as your skin, okay, just the way a human skin would work. I'll come back, you might think that I'm a little bit loony on that, but I'll come back to it. All right, and then what you do is, if you look at the next slide, is we have divided the building into several pockets to allow the wind to penetrate through. So the building, again, is breathing all around. It's no longer a solid object. That's exactly what we want to change. The perception of creating buildings that are solid, that are just a drop on the earth, but rather we are creating a biomass that reacts and interacts the same way as any other living organism within the ecosystem. When that is done, okay, you would have a building that is basically being put like a tree on this planet, and you have other living organisms, other birds, even trees, growing and making this their own home as well. So we're no longer taking from the earth, we're actually giving it. Next is the idea of, and this has been around for a while, which is vertical farming and aquaponic farms. So basically, your waste is actually treated. If you look at the bottom here, if I can get the pointer right. Where's my pointer? Anyway, you see that blue part at the very end? That's the aquaponic farm. And what it does is it acts as a biomass, renewable energy, and it's also a waste treatment facility for your building. The energy generated from that and the water treated from there actually goes up to feed your trees that are found on the communal gardens, the greenhouse gardens, and they could be used for your interior water uses. The next concept, okay, is for it to actually, the membrane itself, remember I said we will allow water to come in, so the water, through that smart membrane, could actually be collected and then regenerated back into the building and put into use. So again, we're not wasting water anymore. All right. Okay, so now, for those of you who thought I was loony. Now imagine if we were in a city that follows the same principle as the eco-industrial park, and the city was then divided into community microgrids that are powering itself. Then imagine that the building itself is also self-sustainable. We would need the good technology for it. So let's look at some of the smart materials and technologies that have been around. They're under process right now through various institutes. The first one is MIT's artificial leaf. Now, the artificial leaf is actually a solar collector, and what it does is that even though it gets its power from the solar energy, it could split the sun power into water. It could split the water into hydrogen and oxygen, and it is capable, as you can see, at the moment, okay, of producing around an efficiency of, I think it was 2%. Yeah, 2%. Okay. But they are optimistic about it, and they believe that they could reach up to an effectiveness of around 5%. Now, the common collectors nowadays, the PV panels, are at around an efficiency of 7%. So that's not bad, right? I mean, it's kind of close to it. So imagine a membrane that is created by something like this leaf. Of course, I'm not talking about the main structures. The structure, you can't do anything about, holding the building together unless you can come up with new technologies, which is going to come up soon. Now, transparent solar panels. Previously, we had an issue with that. The PV panels always had that shape, right? Nowadays, they've created a very clear and transparent solar panel. Currently, it's still at around 1%, but they believe they can go up higher, which is good, right? Yeah. Green cement. And this is what they're trying to, right now, if we're looking at structure, okay, they're saying that they created this green cement. This is something that the biomunicipality is actually encouraging the use of. So what they're trying to do is create cementitious material, okay, that uses around 50% less of carbon emissions from the usual working cement, and it uses around 50% less of water demand. So again, this is something that is already in the market and we could start utilizing. Other uprising trends, I think I'm almost running out of time, so I'm not going to go much in details, but basically we have the carbon conversion, so it basically takes the waste of carbon, and scientists have found a way for them to regenerate it into a liquid or a chemical form, and that could be then used into the production of other materials. So even though we could have a high carbon emission, there's always a solution to it. Next is the fourth generation reaction, the nuclear waste. Right now, the first model of nuclear energy used around 1% of the available energy in uranium. Only 1%. Imagine it. Not very effective, right? There's a lot of waste. We're talking about 99% of waste. The new generation, nuclear 2, right now is already extending the already mined uranium. So we're no longer reliant on the raw material itself, but they're actually taking up the uranium which is already used, and they're extending it, they're treating it in such a way that they could raise the effectiveness of the energy power from uranium. And what it does, in that essence, is that it would reduce its radioactivity levels and its toxins in a matter of centuries rather than millennia. So it's not that harm, doesn't create that harm to us, right? Another one is the self-healing materials, and this is also something that has been developing throughout the years, is that they've created materials that can actually heal from any cuts, from any tears, from any cracks. Of course, this is not a structural element, but these are just the common materials. But what that does is that we are reducing the demand of new resources, and of course, it could give you a longer durability of the material itself. Next is the energy efficient water purification. And what this does is that they have provided technologies that are able to, just reduce the demand for water and energy by 50% through smart ways of purifying and sanitizing the water treatment plants. So yeah, I mean, there are a lot of technologies, there are a lot of scientists out there with genius minds, and I hope we can reach up to their aspirations of one day. But I mean, what we are talking about as a concept may seem a little bit off-tuned to a lot of people, but it is doable if we change the process. As I said at the beginning, it's not a matter of just treating sustainability at the very end, but rather it's about getting the process right, about really getting us away from the raw resources and trying to make out of that 20 kilograms of waste, just trying to make the best out of that rather than going back and extracting new materials. So with that, I thank you for your time, and I'll take any questions, and I'll leave you with this little quote of mine that I found that was very interesting to me. And basically what it says is that sustainability is a concept, it's a simple concept, and it's not a matter of not doing, but it is a matter of doing it in the best way scenario. So with that, thank you very much, and if you have any questions, I'll be happy to take them.
Okay, thank you very much. If you do have a question, please do raise your hand. We'll come to you. If you can tell us your name and designation.
for your presentation. My name is Ali Bassam. I work as a consultant with KK in Saudi Arabia. And my question is basically regarding how do you see the functionality of the value sustainable building in Saudi Arabia and the GCC region, especially with the hot and dry environment and the lack of the natural resources?
Sure. Well, again, the biosustainable building, just like any local species, would have to be created in a way that it actually adapts to the local environment. So we don't want to create something that basically treats you for a cold weather, whereas you are putting it in a hot weather. Similar to just like, animals with thick fur who are located down the whole region, and those of us who are a little, less hairy, so we can adapt. So it follows the same principle. The membrane should be designed very specifically to local environments. And it should basically, for example, in the Gulf region, if we're talking about humidity, the membranes of the water collectors should be a little bit higher than those that are going to be in the cold regions. Again, this is still a concept, a theory that we are developing, and we're looking forward to publishing something about it very soon. So hopefully we will take your comment into consideration.
Thank you for your question. Thank you, Engi. Any other questions from the floor? Thank you, sir.
Just a question about the biosustainable buildings. Are you building a complete model for such an application here in this region?
No, this is still at a theory level, so we won't.
As a student manager, as a facility manager, are you looking to build such a model?
Why not in the future? If we found the right materials to build such a structure, of course we could test it out.
I mean, in terms of design-based, how far you are in having a complete design for such a...
Oh no, we're still at the very early stages of this. So.
Any other questions from the floor? Going once, going twice, 3 times. So, thank you very much, Engi Jabba, and thank you, ladies and gentlemen.